low frequencies, the loop will respond with more voltage than it does at 12 kilohertz. 12 kilohertz into this type of load is going to take the response down probably around 3 dB, and with the transformer maybe even a little more. But by that frequency, by 12 kilohertz, you're already past the biggest part of the spherics and the other natural radio sounds that you want to hear. And it tends to help reduce out of band and above audio spectrum response, and therefore it helps reduce intermodulation even more. So that's basically how the electrical circuitry inside works. The next thing I'm going to do, it's going to be a little clumsy, a little awkward, but I'll go ahead and do it anyway, is we're going to start on the T assembly. Now, first thing I'm doing on the T assembly, this one's already been prepared, so I'll just show the steps as they were done, is I drilled 3 holes in a triangle, and they'll take the 832 brass screws that I'm using for terminal studs. Now, because I'm going to make this loop adjustable, both my bearing angle and my azimuth angle, tilting the loop this way, I've cut slots. Use my hacksaw, and I'll just use this as a representation of the blade. Cut this way down the whole seating length of the pipe, which is about 1 inch. Same thing on the sides, and I'll be putting clamps on each of these ports. And this is a good time to show the transformer assembly. The transformer assembly has the screws soldered to each of the 3 wires of the transformer secondary. And I'm going to turn the camera's light on because we're going to get inside. I'm a diabetic, so I used a test strips vial as my inner container. For your transformer and your resistors, for electrical assembly, you need to use a waterproof container. You need to hang the wires to where they come out of the container's bottom, so when it's inside the T and assembled, that any rain that gets in the loop will drip off the wires rather than going inside the assembly. I'll pop the lid off the assembly and you'll see the MET 23. It's awful to have to look because I'm supposed to know. It shows the MET 23 transformer and the 2 resistors. Okay, the bleeder resistors going from primary to secondary. Oh yes. Show the shunt resistor. Okay, you see the shunt resistor across the primary, and then the static discharge resistor. None of the absolute polarity of these connections is important unless you're going to do several loops and use directional characteristics or otherwise use several. Now on the cap I filled the space with silicone rubber RTV compound, help keep the water and moisture out as well. So when I cover this, I have a protected transformer assembly to keep the rain out of the transformer. And that's essentially the electrics. Now I'm going to pause, and the next thing I'll show is a T that's assembled. Here we have the completed T assembly. See the transformer housing assembly here. We got hose clamps. You remember we cut the notches out of each one of these ports to where the hose clamp can clamp around the pipes. So you loosen the clamps, you make the adjustments, and you tighten them back up. Okay, we have a number 8 screw. These are 1 inch long. We showed previously where they were soldered, 1 to each wire. We have a washer on the back side and one on the front side under the nut. We also have a washer up here under the knurled nut, so we have essentially good old-fashioned binding posts. From here to here we have 1600 ohms, or 1.6K as it's sometimes called. From the center tap to either we have 400 ohms. This is the completed T assembly. Well, before we go on to the next section, I'll go ahead and go over a few things about the electrical and T part of this construction video. First, there's two major suppliers for the transformer I'm using for that wideband telecommunications transformer. Mouser's probably the easiest to get it from. Their part number is 838-MET-23, and DigiKey also carries it. Their part number is MT4148-ND. Both companies are accessible online, and shouldn't be any problem to order one if you need one. They're about $16. Well, it's not critical to use any particular size wire for wiring on the transformer assembly. For ease of assembly and for ease of connectability, let's say, on the primary side for the loop I'm using 18 gauge 2 conductor standard lamp cord. It's easy to connect to the 14 gauge loop winding. Short distance here, the resistance is no real factor to consider, and 18 gauge works well with 14 because we're going to use wire nut solderless connectors to make the connections, and they'll work good on that combination of wire sizes. The secondary I'm using probably about a number 22 gauge stranded wire. It just came out of a piece of computer cable or some kind of electronic cable. Using black as my center tap. I'm using white as one end and red as the other, and of course, as we've said before, from black to either white or either red will give 400 ohms, and from red to white will give 1.6K. At this point, I guess I should mention that no part of this loop uses shielding for two reasons. First, this loop is designed to be about 30 feet behind a normal house or normal home, and in an area like that, for the magnetic purposes, you don't want it to be near a power line, so therefore any electrostatic pickup is going to be very little, because first it'll be in a spot where there's no power lines nearby, and second, the size of this loop is not going to permit very much electrostatic pickup when you compare it to the low impedance of the loop circuit. Of a 3.2 ohm loop circuit, it won't even have a potential to pick up any hum. So we don't use shielding for that reason. For another reason we don't use shielding is because it makes the output totally floating, ungrounded, so the output will feed well into either a coaxial feed line or into a balanced feed line, whichever you choose, regardless of which terminal you use for what function. You're completely reversible as far as grounds and signal, or completely free to use any terminal for either side of a balanced line, and because of that, unshielded works very well, and because it's in a backyard and not near power lines, it won't pick up any interference anyway.